Okay, we're on the top of page 180, and again, on problem number 4, try to figure all of those out. And again, I don't really want you to memorize rules. I want you to try to, if you're not sure, write it out at the kind of the DNA level, like what is that probably really telling you to do, and then go from there. Okay, so your answer should only have a number, a coefficient. It should have an x to some power, maybe a y to some power, something like that. But you shouldn't be able to mush these completely, because remember, when you multiply, you're creating a new shape. So like with fractions, if you have, let me find a pen here. Like with fractions, remember, if we had 2/3 times 4/5 or something like that, we didn't need to get a common denominator because we're creating something new. So in all these, you're mushing these. You should be able to mush and get a coefficient, mush and get x's, mush and get y's, and mush and get z's or whatever, and have a single chunk as an answer. So try the top of page 180, number 4, try all of them, and then we'll see how you did. Okay, so let's look at these. So again, I don't want you to memorize rules. I want you to think about what's going on here. So this is 17, and x squared means x times x. And then you have a 2, and then x to the 5th means x times x times x times x times x. So multiply your coefficients, you end up with 34, and you can mush this completely. So you have 1, 2, 3, 4, 5, 6, 7 of them. Now again, coefficients, numbers are normal, so don't start adding numbers. 17 times 2 has been 34. The rest of, all your life it will be. Now with exponents, when you're multiplying, you can add exponents, but the only reason you can add them is because you are counting them, and so that's why that ends up adding. Because when you were a little kid and you learned to add 2 and 5, when you're little, what you did is you counted them, and then you realized, like, oh, the answer's 7, okay? All right, the next one, let's come over here. Again, if in doubt, write it out, but I want you to make sure you understand this. This means you have 2 sets or 2 groups of this. So you have 4x to the 4th, and you have it twice, okay? And then what does each of these mean? Well, that means you have 4 x's, and that means you have 4 x's. So if I can mush this together, 4 times 4 is 16, and then I have 4 x's here, 4 x's here, so I have 8 x's. And again, I can figure it out by writing it out. But if you want to think in terms of like math rules, you have 2 sets of that, and 4 times 4, or 4 squared, has always been and will always be 16. That's where that comes from. And then you have to kind of do that as well. So you have 2 sets of 4. So again, think of when you were a little kid. If you had 2 sets of 4, you might have had a domino or some type of drawing. And 2 sets of 4 is multiplication. That has 8. 2 groups of 4 is multiplication. It's 8. So when we have sets, we multiply. When we're counting, we add. So again, you can get that a couple different ways. All right, I'm going to have you pause, try the rest here, and I'll pick up. Okay, let's look at this next one. I have 2 sets or 2 groups of this, so I'm going to write it twice. And then I'm going to write it even more just to get it down to kind of that DNA level. And so a negative times a negative is a positive 25, and I have 3 x's here, 3 x's here, it is 6. Now again, if you kind of want to be a rule person, that's fine, but you got to make sure you do them right. This means I have 2 sets of a negative 5. Well, a negative 5 squared, a negative 5 times a negative 5 is a positive 25. But I also have 2 sets of x cubed, and 2 sets would mean I multiply, because 2 sets of 3 would be 6, and that's where that comes from. Notice I can mush my answer into one swoop. Like I have a coefficient, I have all my x's mushed together. All right, the next one, anything to the 0 power is 1, okay? And notice this is in parentheses, which means that 0 goes with all of it. This one, notice the 0 is just touching the 8. There's no parentheses to say it's a negative 8. And some of you are like, but it's a negative 8. Well, you don't know that. It might be 20 minus 8 to the 0 power. And so that this is that exponent's only touching the 8. So only this is 1. So then the negative is still there. So this is saying the opposite of 8 to the 0 power, which is a negative 1. And that goes with order of operations, and we'll talk about more of that later. All right, so again, these are similar but different answers. All right, let's look at this next one. This means I have 2 sets or 2 groups of all of this. So I have 3x to the 4th over x cubed, and I have 3x to the 4th over 6x cubed, okay? And so then I could write all these guys out. I would have 3xxxx times 3xxxx all over 6xxx and 6xxx. So again, if in doubt, write it out, or even if you're not in doubt, it's a good idea. All right, so these x's would cancel or reduce. These x's would cancel and reduce. 3 goes into itself once. 3 goes in there, twice. 3 goes in there once. 3 goes in there twice. All right, so it looks like I end up with an x times an x, which is x squared. And then it looks like I end up with a 2 times a 2, which is a 4. Now, there is another way to get that answer. Okay, so the other option here is to simplify first and then do the squaring. Okay, and we obviously should get the same answer, otherwise something's wrong here. So I could do my order of operations first and say I'm going to reduce this. So 3 goes in there once, 3 goes in there twice, so 1/2. And then I have 4 x's on top and 3 x's on bottom, so all of them are going to cancel except 1. Because if I have 4 x's on top, 3 x's on bottom, they're going to reduce or simplify, and there's going to be 1 left. But then I still have this squared. So now it's saying I have 2 sets of this. Well, x over 2, if you want to leave the 1 off, it doesn't matter, because there's an invisible 1 there, so it's either way is fine. So I have 2 sets of this. Also notice I have to have, like, not really distribute. I have to have 2 sets of this, but I also have to have 2 sets of that. So then when I multiply across, I get x, or you could put 1x if you want, over 4. I lost something here. Oh, duh, x squared. So I have x times x, which is x squared, and then I have 4, which notice if I square that and square that, I also get that. So either way, you're going to get the same answer, just kind of depending on if you want to simplify first and then square, or square first and then simplify at the end. All right, why don't you try G and H, see how those go. Okay, now again, try these on your own, and when you look at your answer, see, do you have a single coefficient, do you have a single power of x, or x to some power, excuse me, and then y to some power, and then the bottom one may be z to some power. So you should be able to mush these completely. Coefficient, x to some power, y to some power, maybe z to some power, and you're done. All right, so again, if your answers aren't in that format, then there's an error. All right, so let's look at this. Order of operations, which we'll get to in another video here, is I've got to get my answer to the top, answer to the bottom, and then I'm going to divide here. So I have 2 sets of that. So again, if in doubt, write it twice and make sure you know what you're doing. If that doesn't help you, write it even down to the bare minimum of what it is. So 3 times 3 is 9. I have, 2 x's, x squared, and I'm multiplying y times itself 4 times. Now again, some people can look at this and be like, well, I'm going to have 2 sets of that, or 3 squared is my 9, and I'm going to have 2 sets of that, which is going to be x squared, and 2 sets of that, which is going to be 4. So, kind of up to you. All right, let's look at the bottom here. It's just 3y cubed. All right. So now I'm going to simplify. Numbers are normal, so just do what you normally would do. 3 goes in here 3 times, 3 goes in there once. And then my variables, I'm going to cancel. So let's see what happens here. X squared, there's no x's down here to cancel or simplify, so they're going to be there. And then here, I have 4 y's on top and 3 y's, so I'm going to cancel. And again, you can subtract, because when you're canceling, they're going away, and there's y. If you want, we don't usually do it, but you could put a 1 there. Or technically, you could put a 1 here. But this is a little cleaner, has less junk written. So even though mathematically this is correct, probably my math lab and stuff is going to want that one. All right, let's look at the next one. Okay, we're going to ignore all this. I just kind of had to back up my video a little bit because I did not write the exponent, so I solved the wrong problem. So I'm going to pause it, write the right problem, and then we'll pick up from there. Okay, all right, so yeah, I'm having troubles over here. So I am going to erase this. Sorry, I can't edit very well in this video. So, all right, so I need to have 2 sets of this, so I'm going to write it correctly, which I'm having a problem with today. All right, so I have 2 sets or 2 groups of this. So again, 4 times 4 is 16. I have 2 x's, 2 x's, so I have 4 x's, 2 y's, 2 y's, so I have 4 y's, and I have a z and a z, so I have 2 z's. Now again, you can add the exponents. You can even write them out more if you want, but you're counting. All right, so that's that part. And then we still have this part. All right, and again, remember, you can mush completely. So 8 times 16, I get an answer of 128. So I can get one coefficient for the whole thing. How many x's do I have? If I count them, and again, if you need to write this out, write it out. I have 5 of them. Y and y, again, I have 5 of them, and z, and let's see what z, I would have 3 of them. All right, so my final answer is this guy right here. And notice how it's mushed. I have a coefficient, I have x to some power, y to some power, and z to some power, okay? And again, if you're like, but you need to add exponents, well, technically you could put 1s there, and you could add your exponents, but again, it's better to think of it as counting. All right, let's see. Why don't you try number 5, A, B, and C, and maybe look at 6, A, and B, and then we'll come back and finish up this video. All right, so let's look at 5, and if you didn't do letter C, that's fine, because I think you're going to be okay. So I can do it if you want, but that one's a little on the trickier side. So, all right, so let's look at this one. So number 5A, it says find the area of a triangle. So go back and look at that formula sheet. The reason it's half base times height is because a triangle is like half of a rectangle or half of a parallelogram. So that's where that half comes from. So, but we want to put the units in here because I want you to see something. Base is 5 inches and height is 20 inches. Now, if you want, you can multiply straight across on a calculator, or you could get 100 and take half of it, up to you. But notice, inches times inches, kind of like x times x is x squared. So notice inches times inches are square inches. So because your unit is changing, when you multiply, you create new shapes. So even though that I have something that it's like, okay, well, you know, I have this triangle, the base is 20 inches and 5 inches, and they're not certainly squares. But then when I find the answer, I'm getting an answer of a new shape that these are squares inside here. So again, when you multiply, you create new shapes. That's why when you do something like this, you get a new exponent. Just kind of like when you multiply fractions, you get a new denominator because you're creating something new. All right, and then B says find the volume of a cylinder. So again, look up your formula and sub in your values. So the radius is what, 2 centimeters and squared, and the height is 1. And again, if your units don't match, you're going to see it. So like if you have inches with feet, you might have to convert. Order of operations, I got to do this guy first. So 4, let's see, was that, oh, there was no squared in there. All right, so 4 square centimeters and 1 centimeter. So after I square it, they become squared. All right, and then if I multiply my pi and my 4 and all that good stuff, I get about 12.6. Now notice I have centimeters squared, centimeters, so now I get a new unit of cubic centimeters. Okay. All right, let's skip C. That's not that important. All right, and then let's go to the top of, oopsie, move the eraser. The top of the next page, 6A and 6B. So if you didn't do those, look for the formula. I'm going to pause quick and you try those. Okay, so if we find the area of this guy, we have 3 centimeters times 3 centimeters. So again, if you multiply numbers are normal, I'm going to end up getting a 9. And centimeters times centimeters, I get centimeters squared. Just like 3x times 3x is 9x squared. So I'm creating a new unit. And why do we call it 9 squared? Well, if you look at the shape, it is definitely a square. So that's why we pronounce that centimeters squared. Down here, and again, I'm not super good at drawing, but you can kind of get the idea. But if I take 5 feet times 5 feet times 5 feet, I get 125. But my unit becomes feet cubed or cubic feet. So the reason we sometimes call this 5 cubed is because it makes a cube shape. And this guy is 3 squared because it makes a squared shape. So because this makes a cube and it's, notice, 3-dimensional, this makes a square, which is 2-dimensional. That's why we call that 3 squared, and that's what we call that 5 cubed. Now, fractional exponents are just like square roots. So like the square root of 25 is just the same as a fractional exponent. So again, if you see fractional exponents, they're just like square roots, cubed roots, fourth roots, things like that. All right, I think we're pretty good with this one.